right, who is Millicent Ocheng. She is a data and applied scientist at the Microsoft African Research Institute, with a master's in data science from the Africa Center of Excellence in Data Science, University of Rwanda, right? And then her current focus lies in the evolution of large language models and automatic speech recognition for African languages, particularly with regards to multilingual capabilities. Her research interests encompasses natural language processing, machine learning, and computer vision, with a focus on exploring the applications in three major domains: that's health, the new future of work, and the society and stability. She's also a WIDS ambassador, as you can see on here, and has been part of the Worldwide Ambassador Advisory Council since 2002. Millicent to 2022. Millicent is passionate about youth empowerment, particularly mentoring girls, and enjoys traveling and exploring new places. So take it over, Millicent, with our data and AI fundamentals session.
Thank you very much, Dee. I'm excited about this session. So, in this session, um, we are not going to write any code. As I've always, I mean, told many people who approach me, like, where can I start, and all these kind of questions about being a beginner in the field. Like, it's not always about the code. First of all, let's try and understand the concepts, right? Uh, these concepts which we'll be writing codes for, right? Otherwise, it will be a huge wastage of time just trying to write in codes and yeah. So I'd like to start. This session is called with Kenya Data Drill. So let me just give you a very quick overview of what WIDS is. So WIDS is short for Women in Data Science, and this is Kenya chapter. Otherwise, we have Women in Data Science. Women in Data Science is a program that was started by with Stanford as an independent event. And then, they started this program to promote data science globally, but then to ensure that like their mission to fulfill their mission, they started regional events, chapter for regional events. So like call for ambassadors, and these ambassadors would host WITS events in their regions, and just to promote data science in their regions, because promoting data science in individual regions across the world leads to like massive in promotion of data science globally. So the way in which we promote data science is through events like WITS conference, and then later on, with Stanford started another program called WITS Datathon. So Datathon, so the way in which the conferences are hosted is like we invite speakers in the field of data science. We bring in a topic of discussion, and then we bring in these phenomenal women. We highlight phenomenal women. The speakers must be women, to come and speak in these events to motivate and inspire individuals or attendees for the events, right? But then they wanted to go beyond just having attendees attend events to listen to speakers by just having them have some hands-on data science work. So that was how Week's Datathon came up, and we've hosted here in Kenya, we've hosted Week's Datathon twice. It started back in 2019, and they've been wonderful, right? Because it is from WID's Datathon that we started WID's data drill sessions, whereby our attendees just came up with this idea, like why don't we have these sessions for data drill where we invite uh, people or like newcomers in the field to just give them a community where they can feel free to kind of like chat with advanced people in the field to grow, right? So our purpose is to grow everybody interested in the field of data science through these sessions that we host. So for example, in our last session, which was the very first session, it was about uh, we it was a session where we were going through um, our past datathon uh, our past datathon like session, like uh, all the things that we needed to do for that datathon, right? So we're just covering up that, a recap of the week's datathon. And now in this session, we said, um, before diving deeper into machine learning stuff and AI, why don't we have a session where we talk about like fundamentals of data and AI, right? So this is and that's how we came up with this. So let's see what we have here. So I'll also be admitting people, and okay, good. I just admitted someone. So I'll go straight to what this. So thank you very much, Dee, for the introduction. I'm Millicent. I'm a data scientist at Microsoft, and welcome to the data drill session. Today, I'll be talking about data and AI fundamentals. So during my talk, I'll talk about data, what it is, different types, and sources of data. I'll talk about how we can collect data and how we can pre-process it. I'll go further to talk about AI, right? Its definition and ultimate goal. I'll talk about AI techniques and the application areas, and I'll touch a little bit about ethical considerations in training AI models. And yeah, in case you have any other thing that you want me to mention or to just explain it for you, please feel free to ask me anything, even if it is outside this content. So what is data, right? I believe we all know what data is, raw facts and observations, right? Or measurements. So measurements that we collect for the purposes of analysis or those kind of, or decision making, for decision making purposes, right? And it's very, very crucial that we make decisions based on some data-driven facts. So data is the foundation of AI. Later on, we will talk about AI, but I just want to mention at the beginning that for AI, we have data as its foundation for all AI systems. And it plays a crucial role in deriving insights and making informed decisions. So we all know data is simply just raw facts and uh, measurements. What are the different types, right? We have structured data, we have unstructured data, and we have semi-structured data. What are they? When we talk about structured data, these are data that are organized in rows and columns, right? Tabular data. Yeah, and I mean it's some kind of like you are a vendor and you have like you have like your customers and the sales record stored in some Excel spreadsheet. That is a very structured data. We have, when we talk about unstructured data, this kind of data is data that doesn't really have a predefined structure and doesn't fit neatly in in traditional tables or spreadsheets, right? When we talk about unstructured data, we talk about textual data. We talk about data in emails, like social media posts. We talk about images, audios, YouTube videos, and all those. Those are very unstructured kind of data. The other thing, the third one is semi-structured data, and so these are data that um, does not really fit into a rigid structure. But I mean, they don't they have some organization, but they don't really fit into the rigid structures of the structured data, the spreadsheets, right? So when we talk about this kind of data, we can store them in as like XML files or some JSON files and some log files, right, to be able to store this kind of data. So the types of data would simply be, when you talk about the, especially the structured ones, these are numeric kind of data, and then we'll have like text data, very unstructured. We have audio, we have images, and we have, so data, as a data scientist, you must be able to know how to handle these types of data, right? The other thing is the sources. Where can we get or extract this data? We have like public, the main sources are like categorized broadly into three. Like we have public sources, we have private and semi-public sources of data. So public data, we have places such as Kaggle, very has like millions of data sets that you can use to like do some practice with. And in Microsoft, we have Azure Open data sets. They are also open to anybody who wants to kind of like use them for their business. Then we have private data. So these are data that are collected from internal sources. So like Microsoft only data, and this data cannot be accessed by anybody else. Like it is Safaricom data, strictly that, right? And then we have semi-public data. So for example, in Microsoft, sometimes we have some data that we use internally. However, we can share it to probably students if they want to use it for their education research and stuff like that. So we call that kind of data semi public data. So how do we collect and pre-process the data, right? Data can be collected through surveys, interviews, observations, through automated data collection processes such as using sensors, and for text and even videos, audios, we can crawl or scrap, web scrap the data, right? So some of the ways, and not only the ways, there are so many other ways, but just to mention a few, these are some of the methods that we can use to collect data. Data quality and data cleaning. You must ensure that the data that you're working with, for whatever reasons, training a model or even just finding some insights, it must be of very, very high quality, right? Ensure high quality data for accurate analysis and reliable AI models, right? Otherwise, your model is going to be very, very biased. Yeah. And the common issues that exist in data quality include stuff like missingness, inconsistencies, and outliers in the data, right? And so data cleaning is very, very crucial to address these issues. And this is why we have pre-processing. Whenever you, before doing any super interesting visualizations or training a model, you must do something called data pre-processing. So when you pre-process data, you want to ensure good quality of data. So common practices when it comes to data preprocessing include stuff like data normalization. So when it comes to data normalization, let's say you have like you are training a machine learning model to detect, like, I mean, to default or non-default. You are doing a credit score model for a bank, and you have some data in dollars, you have some data in Kenya shillings, and so you want to normalize them um, some standard currency or so, that kind of thing. We have feature scaling, yeah, and I think these are stuffs that Brian talked about as well in his previous presentation. So I'm not really going to go deeper into them, but they will help you pre-process your data, handling missingness in the data and detecting outliers, right? So at the end of the day, data preprocessing simply helps you um, um, to prepare the data for your analysis and improve the performance. I mean, to improve the performance of your model. But I really wanted, now let's go to the giant in the room, AI. What exactly is artificial intelligence? So this presentation, we have some data and we have AI. So we've agreed that data forms the foundation of AI. So what exactly is AI? Can someone actually just post it on the chat just to give me 1 minute break? Like, what do you think AI is? I'm sure you must be thinking about something when it comes to AI. So what do you think AI would be? Just a one liner, like AI is you can even say AI is a machine, AI is something, or you can just unmute yourself and say it. But anyway, um, let me see if someone is typing. Even if we get one, and please post your questions on the chat. Is my little understand. Oh, so Brian just posted that AI in my little understanding is the technology of having machine mimic human behavior. Thank you very much, Brian, for that. And yeah, let's see about that. But that is exactly what AI is. Titus, you want to say it verbally?
Oh, okay. I want to just to add on whatever Brian has said there. Actually, the
Interesting.
AI
Yes.
from AI from my understanding is
Yeah.
just the artificial intelligence, like how the brain of a human being works, and maybe being implemented in a machine so that the machine just performs almost
Exactly.
similar to how brain works.
Exactly. That is exactly what AI is. So some is also saying AI or artificial intelligence is the field of computer science focuses on creating intelligent machines that mimic. So the goal is just to mimic human intelligence, right? And perform tasks autonomously. That's really what AI is. So let's just look at a quick overview of AI before even giving it an official definition, right? So artificial intelligence, it has been very an integral part of our daily lives. Like we use this AI thing daily in our lives. So let's see how that happens. When we type in something in Chrome or Microsoft Bing, you start typing like, what is the something starts to pop up, right? That is AI. That is next sentence prediction in natural language processing, right? That is AI. You start typing something in your smartphone and then something starts to pop up. It's also, again, next word prediction, another important component of AI. The other one would be I mean, I don't know whether you guys have tried it, but Microsoft Bing or Google Bing Translate or Google Translate, you can actually check what a word in um, in French would mean in English, right? Machine translation, another important component of AI. We also have stuffs like Cortana or even Siri, and you all know how these um, are really interesting, right? We have stuffs like, now we have like ChatGPT. And I don't know if you guys have used ChatGPT, but ChatGPT is just super, super awesome. And all this, we are interacting with AI. I probably know, we know because we are data science enthusiasts, but that was just a quick overview. So what exactly is this AI? So AI is a replication of how the human brain thinks, learns, decide, and works when it tries to solve problems, resulting in the creation of intelligence. In so the end goal is like we try to mimic how human brain thinks and works, and at the end of the day, we want to end up with an intelligent system, just like a human brain, right? So intelligence in artificial intelligence can loosely be defined as the capability to obtain knowledge and skills and to apply those skills in like various setups like reasoning in terms of learning and problem solving, perception, talk about linguistic intelligence and those kind of stuff. So machines nowadays are trained or are just designed to have the capabilities to perform tasks by learning, right? I just want to say like the end goal of AI, as we've all agreed, is um, to develop systems that can work intelligently as humans and also independently, right? Very intelligent and very independent at the same time. So let's see what are the components or techniques in AI, right? This is where we come and talk about different subsets or branches or the techniques, whatever you want to call them. So let's start with machine learning, which is a technique that gives computers the potential to learn without being programmed. We all know about machine learning. But then in this presentation, I'll go deeper into what machine learning is. So let's just closely define it like that. We also have another component which is very interesting, my current interest. It's called natural language processing, which deals with searching, analyzing, and understanding and deriving information from textual data. And now let me just don't jump, but now we have speech recognition, another important component of AI, which deals with developing methodologies and technologies that enable recognition and translation of spoken language. So this one do spoken language. So and then lastly, we'll talk about like computer vision that deals with how computers can gain high level understanding from digital images, simply image recognition. That is computer vision. I'll dig deeper into machine learning and 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 deep learning for the sake of this presentation. All these other ones are really interesting, but I would be happy to do a good presentation about natural language processing, about speech recognition, about computer vision, but just know that these are important techniques in machine learning. So what exactly is machine learning? We've just defined it, but then machine learning is a subset of AI that focuses on development of algorithms and models that enable enables computers to learn from data and make predictions or decisions without, so the keyword is usually without being explicitly, you don't have to explicitly define things, like without explicitly program. And what a machine learning model will be doing is a machine learning model will be extracting patterns from your data, right? And I'll show you that in a bit. In machine learning, we have three important problems. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. For the sake of this presentation, I'll talk about supervised learning and unsupervised learning. When it comes to supervised learning, this is a component of machine learning. So this is a problem, like if data given to the model is labeled. So I just did some pictures here. You see that we have fruits and these fruits are labeled. So if the examples you're giving to your model is labeled and the task is to predict labels for new labels, so you train your model with labeled data and you give it another data that is not labeled. You expect your machine to do a prediction. This kind of problem is called a prediction problem, but we really call it supervised learning problem, right? And in supervised learning problem, we have two problems. We have classification and we have regression. When can we say that we are dealing with a regression problem or a classification problem? If the label data is, so when you are training a model, you have predictors and you have the labels. So the labels is what will help us know whether we are dealing with a classification problem or a regression problem. Now, if the label is a category, then the problem there is called a classification problem. However, if the label is real number, right? It's sales in 10,000 Kenya shillings or in dollars. We call that kind of problem a regression problem. The other problem, and then we have different algorithms. So you don't have to build things from scratch. We have different complex and interesting, very basic and complex algorithms that are already built, and these algorithms can be found from like Keras application and all those kind of places. We have these models that have already been built that you can just fit into your model and you just fine tune them for your use case. We have linear regression, we have logistic regression, we have decision tree, and all these etc. There are thousands of them, right? So when it comes to linear regression, I don't think I'm even going to time myself well. I just wanted to ask, when it comes to okay, these models like linear regression. So from you just have to know like what model you are using for what problem. So this one, the way it's from its name, it's linear regression. It will be for a regression problem. And logistic, this is kind of like, we all know logistic regression from, especially if you have math background. This is for binary classification, so it will fit for classification problem, and so forth and so on. So we have the other problem, which is unsupervised learning. And so what or when do we say a machine learning problem is unsupervised learning problem? If the data given to the model is unlabeled and the task is to find just interesting groupings and structures within the data, we call this kind of problem unsupervised problem. So we have this mixture of data and we give it to the model. We just want to extract patterns. There are no labels. Like in the other case, we could see this was an apple, this was a watermelon, etc. grapes. So we just want to classify green fruits from red fruits. This is purely unsupervised learning problem, right? And we have different algorithms to help us with this. You don't have to, again, build your own algorithm. We have interesting algorithms like k-means. Later on, we will see how we can use these algorithms to kind of like to solve our problems. But in this talk, I just wanted to kind of like let you know that what falls under what, right? And that's the purpose. Yeah. And the steps of training your machine learning model, we all say that AI is powered by data. It's the foundation. Data is the foundation of AI. So you have your data, you have to clean it. We've talked about data quality, you remove your missingness, pre-processing, and all those kind of stuff, so that you're training your model with a very quality data. So you train your model, you test your model, you still feel like it's not really so good, then you'll have to go back and improve it. Improving the model and all those kind of stuff we'll see later on, but that's really the flow. Yeah, I lied. My presentation will go past 30 minutes. So let's see how it goes, because I'm just going into deep learning, right? So deep learning is a sample of machine learning that focuses on now training deep neural networks. So machine learning helps us doesn't really represent complexity in the data. When we have complex data, we now need to go beyond training simple machine learning models into training deep neural networks. We call them artificial neural networks, right? Or simply neural networks. These are models inspired by human brain, and I inserted a picture with like how neurons are interconnected in like a human brain. So this is how complex a neural network would look like. So it can help you like extract those patterns, complex patterns that are linear. I mean, it goes beyond just representing linearity in the data. So deep neural network refers to with multiple hidden layers. So they allow us to represent complex patterns and relationships in the data. So so this can be applied in like computer vision, in NLP. When we apply them in computer vision, we have a different kind of neural networks. We call them convolutional neural networks. When it comes to NLP, we call them recurrent neural networks, and so forth and so on. So yeah, I just wanted to do like a small application of deep learning where we apply it in computer vision. Again, I won't go deeper into this, but I just wanted to let you know like how we can use like these neural networks. So these are convolution. This is a good example of convolutional neural network trying to extract patterns from an image. And the more you have your this filters, the more patterns it can extract from an image, right? And then you'll be able to do your classification. Or this image is a cat, this image is a dog, and so forth. These are interesting components of AI that can be applied even beyond just recognizing cat dog in like face recognition system and medical imaging analysis and those kind of things. So we've all seen that deep learning goes a little bit beyond machine learning. So they can help extract like they can help extract like complex features in the data, right? And that's one of their important advantages, handling large and complex data sets. So for example, you cannot fit a linear regression to extract patterns from audios, speech to text. You will be lying. So you'll have to fit in deep neural networks for stuffs like that. And these deep learning models, they are very scalable. Like you increase the layers. So for example, in this example, you increase the layers, you increase your chances of extracting, of improving like the performance of that kind of a model. So just at a very high level, the advantages of deep learning. I'll quickly talk about the applications of, I'll quickly talk about the applications of AI, and I'll start by talking about application of AI in healthcare, where AI has been used in early disease detection. So you see those convolutional neural networks, they have helped really in like detecting diseases in blood smears and stuffs like that. NLP has been used in customer service in building chatbots to help like medical professionals, and in like training virtual health assistants and those kind of stuffs. And I also just wanted to talk about like the projects that we worked on here in Mali. I mean, in my team in Mari, Microsoft Research, whereby we were trying to help medical providers to provide to extend medical provision through chat, because we realize that there are increasing use of like chat, and we can take advantage of that to help medical providers like extend their medical support through a chat. It's a whole I mean, it's a whole project. I can't even go deeper into it for the interest of time, but um, I'll be able to explore more if time allows. The other one is application of AI in banking, where models have been trained to detect fraudulent accounts and fraudulent accounts, and we've trained models. Models have been trained also for credits decision. I mean, for credit scoring, like um, to help financial institution like know who they can trust with their funds, right? AI has been really helpful when it comes to mitigating the effects of climate change. And the first example here would be the first our first, I don't know, the first time we participated in Datathon, like we were building a model to predict building energy consumptions using building characteristics and weather data, right, to help mitigate the effects of greenhouse gas emissions. AI has also been used in some people like just have this ability, this tendency of clearing forests to do their own stuff. So through the sensors and all this kind of stuff, like AI has been used to predict which part of the forest has been cleared, and so that necessary um, I mean, which part of the forest has been cleared by people just doing that for their own benefits, and it is not so good. So it has been used for that as well. AI has been used for improving customer experience, where we use customized data, we correlate it with their information to be able to advise the vendors on like which uh, which products go for what kind of customers. And we all know about recommend assistance from our YouTube. You tap into a YouTube video and there you go with lots of recommendations. They are personal to everybody else. And all these are powered by AI. And we end with AI in agriculture, where bots have been trained to help manage to help people in stuffs like crop harvesting and stuffs like that. It's not like AI is removing the people or the agency, but just assisting farmers in like in this kind of stuffs, like reducing the time that they use during harvesting and those kind of stuff, and in predicting in making predictions. So for example, you can use AI to predict like crop yield, for example, for a given period. Those are also AI applications in agriculture, in weed or crop disease detection, right? AI has been used in that as well. I just wanted to talk a little bit about, so this is a whole, uh, it's a whole, it's a lot. to talk about in like 1 minute. But whenever you are training an AI system, always make sure that you put into consideration good ethics. It is important to practice good ethics as you are training towards the entire AI life, like from your data collection to your pre-processing to training that model and even deploying the model. There is importance of ethics in AI, right? You are dealing with patient's data, right? You must exercise like high privacy when it comes to somebody's delicate data. Responsible AI is a very key. The model that you're training, make sure that it's not like just data in, you then some neural networks, then out. You must be able to kind of like explainable AI, put that into consideration. Make sure your model is very fair. And yeah, this is something that can take a whole 40 minutes to talk about, but I just wanted you to kind of like know that it is great, good to practice responsible AI whenever you're doing all this AI stuff. As the final thing, people do ask me, what kind of skills do I need to kind of like get started in the field of like machine learning in AI? You need a little bit. So okay, I know a lot of people don't like maths, but at least you need to know maths a little bit to be able to, because all those algorithms that I talked about in the beginning, like the logistic regression, like the linear regression, the metrics that you will be using to evaluate the models, there are a lot of maths, right? There are a lot of maths in those models and those metrics. And so you need a little bit of maths or statistics, right? You need your computer science at least for programming, right? And then whenever you're training a model for bank, for hospital, healthcare, right? You need to know a little bit about the domain or in which you are working on at that particular time, right? So that you're not just training things out of blues. And then you want to do your modeling like C sharp or Python, it's up to you. But Python is usually good for building these kind of projects. I want to allow time for like questions. I was hoping to have like 15 minutes, but I ended up having like 4 minutes for questions. Please feel free to ask any questions if you have. But thank you very much for listening. Brian.